Here's a brief overview of IPAC, URSA, the SSC, and how I fit into it. IPAC has now been rebranded as literally just IPAC, but historically this is the Infrared Processing and Analysis Center. It's physically based at Caltech, but it has affiliations with both Caltech and JPL. IPAC's charter is to support many different NASA infrared missions, space-based and ground-based, and archives. Spitzer has been a very significant component of the archives and the work at IPAC, but in terms of just data volume, WISE now wins. Parts of IPAC have either supported or do currently support WISE, Herschel, Planck, some Kepler, IRAS, and many more missions. NED, the NASA Extragalactic Database, is based here at IPAC, so is URSA, the Infrared Science Archive, and the Exoplanet Archive. At least 10% of all refereed astronomy journal articles worldwide today use, at least in part, data that come from URSA, which is one of the largest parts of IPAC. The Spitzer Science Center, or SSC, is an organization that was created specifically to support the Spitzer Space Telescope. It is part of IPAC. You might be familiar with the Hubble Space Telescope. The institute founded to support that is the Space Telescope Science Institute at Johns Hopkins in Baltimore. To support a spacecraft called Chandra, which observes in the X-rays, is the Chandra Science Center, which is based at Harvard and the Center for Astrophysics in Greater Boston. There are lots of other ground and space-based observatories that have this kind of support structure. The NOAO, the National Optical Astronomy Observatories, have a headquarters in Tucson that support both Kitt Peak National Observatory and Cerro Tololo International Observatory. Of the space-based observatories, really only the great observatories have support centers this long. So in terms of missions that are, the great observatories that are ongoing are Hubble, Chandra, and Spitzer, and they're the ones that have sort of big support structures like this. Many other space missions have smaller groups of people that are assembled usually at a university to support the mission. So a spacecraft called WISE, the Wide Field Infrared Survey Explorer, and for that matter, a spacecraft called IRAS, which was the first all-sky survey in the infrared, surveyed the entire sky, and they both were on similar orbits. So the WISE support staff that are based here at IPAC look after the telescope, process the data, support researchers working with the archive, and we're doing the same thing for all the other data that we have. We still support people working with IRAS data. Spitzer, and for that matter Herschel, only point where we tell it to point. It's not doing an all-sky survey. It points at specific locations. So the Spitzer support staff at IPAC look after the telescope, run the process of deciding where to look, tell it where to look, process the data, and support researchers working with the archive. So because Herschel was a European mission, most of the Herschel support staff were in Europe. There was a small core group of people at IPAC that supported the US-based Herschel observers. So a more detailed list of what the Spitzer Science Center does is quite long. So we operate the spacecraft, we make sure that nothing strange is going on. If it does go into safe mode, we help the spacecraft recover and resume normal operations. We write lots of documentation so that astronomers know what Spitzer can do and how to prepare observations for it. We run something called proposal calls. Astronomers propose to use Spitzer typically annually, although because Spitzer is at the end of its mission, it works a little differently right now. Astronomers tend to ask for about 5 times as much time as there is available, so we have to have a decision process to decide what to look at. Basically, we assemble a group of about 100 astronomers that look through all the proposals and decide who gets time and who doesn't. For all the proposals that were successful, we ingest all the observations, review them, release them for scheduling, then we schedule them. Then we assemble a series of spacecraft commands and give them to JPL so that they can be radiated to the spacecraft using the Deep Space Network. Then when the data come back through the DSN, we process the data through pipelines that are written and maintained here. In the past, we looked at each and every frame that came back from the instruments to make sure that everything was working okay. Now we just don't have the staff, so we just spot check things. We also provide the data to the astronomers through the archive and provide documentation to help them process their data. And also, the SSC helps astronomers get media coverage. Any good results that they get or cool images that they have, we help get them media coverage. And for a while, we were developing educational materials, but that money has gone away. And there's other things I'm sure that I've forgotten. And then, of course, the cycle begins again, right? And you run out of observations, you have to have another cycle of requesting observations. So what do? I am on the org chart many times. Primarily, I work for URSA, the Infrared Science Archive. That means that I'm developing, supporting, and testing and documenting many different URSA archives. I'm also the Spitzer archive scientist, so I'm at the interface between the programmers and the astronomers, but within the Spitzer group, to develop the final Spitzer Heritage Archive to make it as good as it can be and as useful as it can be to the future researchers. I also work for the Spitzer Community Affairs team, which basically we run the proposal calls. I'm the director of NITARP. At the very beginning, I used to just do the teacher program on a volunteer basis, but now I do actually get paid for some of the work I put into NITARP. I'm also paid to do scientific research, so doing science is really part of my job. That means that I go to conferences, I write proposals, I go on observing runs if I'm using a ground-based telescope, I reduce data, I write papers, that whole cycle. And just so you know, no professional astronomer spends every night or nearly every night sitting in a telescope. I would be incredibly lucky to get 2 weeks of observing time in a year. And typically a few nights or less of time per year is really typical. If you do want to be the sort of person that spends every night or nearly every night sitting in a telescope, you should look for jobs that are telescope operators, because then you do spend almost every night sitting in a telescope.